Somewhere beneath 100 kilometers of acid cloud, the sun is rising in the west. Venus takes 243 Earth days to turn around once, and it turns the wrong way. For 60 years, nobody has been able to prove why. This is Venus, the planet that spins backwards. The full story. Chapter 1. The planet that refused to show its face. For most of the telescope era, Venus was the brightest disappointment in the sky. Galileo watched it move through phases like the moon, proof that it circled the sun. But when astronomers looked closer, they found nothing to look at. No coastlines, no mountains, no polar caps. Just a blank white shell of cloud, throwing back 3/4 of the sunlight that struck it. Every other world offered something to track. Mars had dark patches. Jupiter had belts and a great red spot. Venus offered a smooth pearl, and a pearl gives you no way to time a rotation. Without one fixed marking to follow across the disk, the length of a Venusian day was simply unknowable. So astronomers guessed, and they guessed badly. In the 19th century, some convinced themselves they could see faint shadings, and announced a day of roughly 23 hours, comfortably Earth-like. Others insisted Venus had to be locked to the sun, one hemisphere in permanent daylight, the other in permanent night. Published estimates ranged from under a day to more than 200. The vacuum of data filled up with imagination. If Venus was cloudy, it must be wet. If it was wet and warm, it might be a swamp, a steaming jungle waiting under the haze. It is worth pausing on how strange that is. Rotation is the most basic fact you can know about a planet. It sets the length of the day, drives the weather, shapes the magnetic field, and decides whether a surface bakes or freezes. By the middle of the 20th century, astronomers had timed the moons of Jupiter to the minute and predicted eclipses centuries ahead. Yet the planet closest to us, the one that outshines everything but the sun and the moon, kept the most elementary secret of all. To read it, nobody needed a better telescope. They needed to stop using light. Chapter 2. The echo that changed everything. The answer arrived as a radio pulse. In the early 1960s, engineers at NASA's Jet Propulsion Laboratory began aiming powerful transmitters at Venus and waiting for the echo to return, minutes later, faint and smeared. Clouds are opaque to visible light, but radio waves pass straight through them and bounce off rock. And the returning echo carries a signature. If the planet is spinning, one limb turns toward you while the other turns away, so the reflected wave is Doppler shifted, stretched at one edge and compressed at the other. Measure how far the echo is smeared in frequency, and you have measured how fast the surface is moving. The 1962 measurements delivered the first shock. Venus was barely turning at all. The echo came back so narrow that the equator had to be crawling rather than spinning. 2 years later, working through the 1964 conjunction with the 85-foot antenna at Goldstone in the Mojave Desert, Richard Goldstein and Roland Carpenter pinned down the second, stranger result. The spin was retrograde. Venus turns clockwise, opposite to almost everything else in the solar system, and it takes roughly 243 Earth days to complete a single turn. The planet that refused to show its face had been quietly rotating the wrong way the entire time. Sit with that number. Venus circles the Sun once every 224.7 Earth days. It turns on its axis once every 243. Its day is longer than its year. No other planet in the solar system does this. Uranus is famously tipped on its side, rolling along its orbit, but Uranus at least rotates in a matter of hours. Venus is a world where the ground moves slower than the calendar. And once that was confirmed, Venus stopped being a boring pearl and became the most awkward object in the inner solar system. Somebody now had to explain it. Chapter 3. A day longer than a year. There are two kinds of day, and Venus separates them more violently than any other world. The sidereal day is how long a planet takes to turn once relative to the distant stars. Modern radar puts that at 243.0226 Earth days for Venus. The solar day is a different thing. It is the time from one sunrise to the next, and it depends on the orbit as well as the spin. On Earth, we rotate in the same direction we orbit, so each day we must turn a little extra to bring the sun back overhead. Our sidereal day runs about 4 minutes short of our solar day. On Venus, the arithmetic runs backwards. Because Venus spins the wrong way, its orbital motion and its rotation add together instead of cancelling. The sun is carried back to the same place in the sky long before the planet finishes a full turn. The result is a solar day of 116.75 Earth days. Sunrise to sunrise takes less than half a rotation, and a Venusian year contains slightly fewer than 2 of them. Stand on that surface with a calendar, and you would watch the sun cross the sky just twice between one new year and the next, rising every single time over the western horizon. The motion itself is almost imperceptible. At the equator, Earth's surface is flung eastward at about 1670 km per hour. The equator of Venus creeps westward at roughly 6.5 km per hour. That is walking pace. A reasonably fit person could outwalk the rotation of an entire planet. Not that anyone is walking. The surface lies under 92 bars of carbon dioxide, the pressure of nearly a kilometer of seawater, at 464 degrees Celsius, hot enough to melt lead. That western sunrise would never actually be visible. The cloud deck is total. The sky is a dull orange lid. Chapter 4. 2 ways to turn a planet over. Now the trouble begins, and it starts with what backwards actually means. Astronomers list the axial tilt of Venus as 177.36 degrees. Read that carefully. It is not tilted a little. It is very nearly 180 degrees, which is to say almost perfectly upside down. Its north pole points south. Described the other way, Venus is a planet flipped completely over, whose axis then leans by only 2.64 degrees. Both sentences describe the same object. And that means a backward spin has 2 entirely different possible histories. Either Venus slowed, stopped and reversed, or Venus never reversed at all, and simply turned over. Picture a spinning top on a table. In the first history, the top stays upright while friction drags its spin down to 0, and then some patient torque spins it back up the other way. In the second, the top never reverses. It tumbles onto its head. Seen from above, a top spinning clockwise while upside down and a top spinning counterclockwise while upright are the same picture. Venus today gives us only that picture. The clouds hid the surface for 4 centuries, and 4.5 billion years hid the path. Both routes end with a planet spinning retrograde once every 243 days on a nearly inverted axis. In 2001, the astronomers Alexander Correa and Jacques Lasker took this seriously in a paper for the journal Nature. They ran the spin of Venus forward through billions of simulated years, sweeping across an enormous range of starting conditions. Different initial tilts, different initial rotation speeds, fast and slow. Their result was not that one history wins. It was that both are reachable from a wide set of plausible beginnings, and both funnel into exactly what we observe today. The question was never simply which story is true. It is what force was patient enough to carry either one of them to completion. Chapter 5. Tides of Rock and Air. That force is tides, and Venus feels 2 kinds pulling against each other. The first is familiar. The sun's gravity stretches the solid body of the planet, raising a bulge of rock a few centimeters high. Because rock is not perfectly rigid, that bulge lags behind, dragged out of alignment by internal friction. The sun then pulls on the misaligned bulge, and the pull acts as a brake. It is the same mechanism that locked one face of our moon toward Earth forever. Left alone, solid tides should have dragged Venus into synchronization, one hemisphere baking, one in endless night, exactly what those 19th century astronomers had assumed. But Venus is not left alone, because Venus wears an ocean of air. Its atmosphere carries about 93 times the mass of Earth's, and sunlight pours heat into it every second. The day side heats, expands and lifts. The night side cools and sinks. That creates a second bulge, made of gas instead of rock, and crucially it does not sit in the same place. Heat takes time to build, so the hottest air drifts past local noon, and the atmospheric bulge leads the planet rather than trailing it. The sun pulls on that leading bulge, and the resulting torque does the opposite of the rock tide. It does not break Venus. It pushes it forward. So the planet is caught between a rock tide slowing it down and an air tide speeding it up. Correa and Lasker showed what happens when the atmospheric torque grows strong enough to matter, and on a world carrying that much air, it does. The tidally locked ending everyone expected becomes unstable. Venus cannot settle there. In its place, four stable endings appear. Two are prograde, with rotations near 77 days. Two are retrograde, near 243. Venus rests in one of the retrograde ones. Its backward spin may not be the scar of an ancient accident at all. It may be an equilibrium, a state this planet's physics actively prefers. Two more ingredients complete the machine. Venus has no large moon. Ours acts as a gyroscopic anchor, holding Earth's tilt steady near 23 degrees for ages. Venus has nothing of the kind, so the gravitational nudges of Jupiter and the other planets can drive its axis into a broad chaotic zone, where the tilt wanders by more than 70 degrees. Meanwhile, deep inside, a liquid core grinds past a rocky mantle, and that friction bleeds spin away. Chaos to tip the axis. Friction and gravity to slow it. An atmosphere to catch it before it locks. Neither route to a backwards Venus required a catastrophe. Chapter 6. The impact that left no crater. Which brings us to the explanation most people have actually heard. Something enormous hit Venus. In the usual telling, a protoplanet struck the young world at a glancing angle and reversed its spin in an afternoon, much as a similar collision is thought to have knocked Uranus onto its side. It is a satisfying story. It is fast, it is violent, and it disposes of the anomaly in a single event. The early solar system really was full of such collisions. Earth's own moon is almost certainly the debris of one. The giant impact idea is not absurd. It is simply, so far, unsupported. The trouble is evidence. A collision powerful enough to stop and reverse a planet the size of Venus should leave marks. A basin the size of a hemisphere. A captured moon, or the wreckage of one. Anomalies in the shape and composition of the crust. Venus shows none of them, and it has no moon at all. But here honesty matters more than a clean conclusion, because on Venus, absence of evidence is unusually weak evidence. The entire surface appears to have been repaved by volcanism within the last few 100 million years, erasing what came before. Modeling work published as recently as 2025 still treats a giant impact as possible. It just cannot be shown. And there is one clue that turned out to be a beautiful dead end. In the 1960s, Peter Goldreich and Stanton Peele noticed something eerie. Venus seemed to turn by almost exactly the right amount to show the same face to Earth every time the two planets passed closest, 5 such passes every 8 years. It looked as though our own planet had reached across 40 million kilometers of vacuum and pulled Venus into step. That coincidence haunted the literature for decades. But the resonance demands a rotation period near 243.16 days, and precise radar has since measured 243.0226. Venus misses. The lock is not real. Chapter 7. The spin that will not sit still. For a long time we assumed that whatever the answer was, the spin itself was at least constant. Then, between 2006 and 2020, a team led by Jean-Luc Margot at UCLA bounced radar off Venus on 21 separate occasions, transmitting from the 70-meter dish at Goldstone and catching the faint return there and at the Green Bank Observatory in West Virginia. 15 years of echoes produced the sharpest picture of Venus's spin ever assembled. The average sidereal day came out at 243.0226 Earth days. The axial tilt was pinned down 10 times more precisely, at 2.6392 degrees. And then they compared the individual measurements against each other. They did not agree. Measurements taken days apart differed by around 3 minutes. Across the full 15 years, the spread reached roughly 20 minutes. Venus does not have one-day length. It has a distribution. The only thing on that planet massive enough to shove a world around like this is the thing lying on top of it. All that air carries enormous angular momentum, and as it piles against highland terrain and sloshes between hemispheres, it trades spin back and forth with the solid planet. Earth does the same thing, and our atmosphere lengthens the day by about a millisecond. On Venus, the air moves the clock by a third of an hour. That atmosphere is doing something else remarkable. While the ground crawls at walking pace, the cloud tops race around the planet in roughly 4 Earth days, driven by winds near 360 kilometers per hour. The air laps the surface about 60 times for every single rotation. Venus is a slow world wrapped inside a fast one. And the consequence is not academic. Margot has pointed out that without an accurate spin model, a probe aimed at the surface could miss its landing target by 30 kilometers. Without these measurements, in his words, we are essentially flying blind. To land on a world, you first have to know exactly how it turns. Venus is what Earth might have been. Nearly the same size, nearly the same rock, assembled from the same debris in the same neighborhood. And somewhere in its first 100 million years, its rotation was decided, either by a blow we cannot find, or by a slow, invisible argument between rock and air that has lasted 4 billion years. Today the ground moves at walking pace, the sun rises in the west onto a sky nobody can see through, and the length of the day depends on when you ask. The real blind spot was never the clouds. It was assuming that a planet's spin is something it is simply born with. Space keeps its best secrets in plain sight. Follow cosmic blind spot and start seeing what everyone else misses.